Hello, this is Team 9, IT Department, batch 2012-2016. The title of our mini project is A Comparative Study of Various Noise Removal Techniques for Images in Digital Image Processing. Our team consists of 4 members, Pragati Kulkarni, Ramya Valipi Reddy, Roja Vajrala and Soumya Shamarthi. We are privileged to have had the guidance from Ms. A. Pavitra, Assistant Professor, IT Department. It is a great challenge to find an efficient method to remove noise from images. This noise can degrade the image at the time of capturing or transmission. Although various solutions are available for denoising them, a detailed study is required in order to design a filter which will fulfill the desired aspects along with handling most of the image filtering issues. In this project, we focus on some important types of noise and a comparative analysis of noise removal techniques is done. Thus, we plan to investigate the results of applying various noise reduction techniques and find better techniques to improve them. Image noise. Noise is any undesired information that contaminates an image. There are several ways through which noise can be introduced into an image, depending on how the image is created. Satellite images containing the noise signals lead to a distorted image, requiring the use of appropriate filters to limit or reduce much of the noise. It helps the possibility of better interpretation of the content of the image. In our project, we focus on 2 types of noises, salt and pepper noise and the Gaussian noise. The comparative study is done on 4 types of filters, the average filter, the median filter, the Gaussian filter and the Wiener filter. Now let's move on to the execution of our project. For our project, we have been using the MATLAB software. It is the version R2013A. First, we look at an image containing the salt and pepper noise and apply the average filter to it. Figure 2 shows us the image where it contains the salt and pepper noise, whereas figure 3 shows us the image, the application of the average filter on it. Similarly, we take the average filter here and focus it on the Gaussian noise. While figure 5 shows us the image containing the Gaussian noise, figure 6 shows us the application of average filter on Gaussian noise. Next, we move on to the median filter. Here, we focus on this image with salt and pepper noise. While figure 7 shows us the image where there is salt and pepper noise present, figure 8 shows us the application of median filter on salt and pepper noise images. Now let's focus on an image with the Gaussian noise and apply the median filter to it. While figure 9 shows us the image which contains the Gaussian noise, figure 10 shows us the image where there is extremely less noise due to the application of the median filter. Next, we move on to the Gaussian filter, where firstly we focus on an image with salt and pepper noise. While figure 11 consists of an image where there is salt and pepper noise present, figure 12 shows us the image where there is extremely less salt and pepper noise due to the application of Gaussian filter. Now we apply the Gaussian filter on an image with Gaussian noise. While figure 13 shows us an image where there is Gaussian noise, figure 14 shows us the application of the Gaussian filter on the Gaussian noise. Finally, we move on to the Wiener filter and we focus on an image with salt and pepper noise first. Here we have 3 types of the images. One is the original image, one is with noise, and one is the image which shows us the application of the Wiener filter. Next, we focus on the Gaussian noise image and apply the Wiener filter to it. Here we have an image which is originally the one with the noise, and finally the application of the Wiener filter on the noise. We have seen the application of all the 4 filters. Now let's do a comparative studies on them. For the comparative study, we used 2 types of parameters. One is the MSE, mean square error, and the other is the PSNR value, which stands for peak signal to noise ratio. The higher the MSE for a filter, the better the filter is. And the lower the PSNR value for a filter, the better the filter is. Now let's firstly focus on a salt and pepper noise image. As we can see here, for the 4 filters, the MSE and the PSNR values are calculated. Now we'll focus on the image with Gaussian noise and apply the comparative studies to it. Similarly, PSNR and MSE values are calculated for an image with Gaussian noise. After we have taken the average of these PSNR and MSE values, we have reached to a conclusion that the median filter is the best filter for xenoid removal from images. Thank you.